Station, this is Houston. Are you ready for the event?
Houston, this is Station, and I'm ready for the event.
United States Coast Guard Academy, this is Mission Control Houston. Please call Station for a voice check.
Station, this is United States Coast Guard Academy. How do you hear me? Okay. Station, this is United States Coast Guard Academy. How do you hear me?
Coast Guard Academy, International Space Station. I've got you loud and clear, Dr. Adrazin.
Dan, great to hear your voice. For our schools, this is Professor Ron Adrazin of the Coast Guard Academy, broadcasting from the Richard Friedman Studios from our beautiful waterfront campus in New London, Connecticut. It is my honor and privilege to introduce to you a 1985 graduate of the Coast Guard Academy, a retired Coast Guard pilot, Academy engineering professor, and NASA astronaut, Captain Daniel Burbank. Dan, please say a few words.
Well, first off, I'd like to congratulate you on doing the mentoring program that you're doing. I think it's fantastic that institutions like the Coast Guard Academy take it as a task for them to start to mentor and reach out to kids in schools all around the country and get them inspired to pursue careers in science, technology, engineering, and math. We need those kinds of skills in the Coast Guard. We need those kinds of skills in all the services. We need those kinds of skills throughout industry in the United States. And I can tell you firsthand, we certainly need those kinds of skills here in the space program and on board the International Space Station.
Thank you, Dan. For this event, hundreds of school kids in 4 different cities competed for the honor to ask Captain Dan Burbank a question. He will be answering questions from students up and down the East Coast. And now to the questions. Our first will be from a new school that after only 4 years is making a huge educational difference in Baltimore, Maryland.
Captain Burbank, to you and the other 5 astronauts on the International Space Station, a huge hello from Friendship Academy of Engineering and Technology in Baltimore, Maryland. Captain, as a general overview, what types of experiments do you do on the space station?
In general, the categories of experiments we do on Space Station range from basic science, physical sciences, combustion research, fluid physics research, for example, to applied technology investigations. So we've got some things that aren't necessarily categorized as scientific investigations, but have to do with how to keep a functioning space station operating in low Earth orbit, and how to keep crews healthy. So we are working to close the environmental control support system loop, for example, to allow us to leave low Earth orbit and go to places in deep space. We also do a lot of biological experiments to support that same kind of pursuit. So on board Space Station, a lot of the research we're doing, and in our case, for the 6 months we're here, it's well over 100 experiments that we're going to be conducting. A lot of that research is we're operating as subjects, we're operating as investigators or co-investigators with researchers on the ground, and we're learning as much as we can about how to keep humans healthy and safe, and how to basically offset the adverse effects of being in microgravity. And some of those things have a lot of applicability to life on Earth as well, for folks that are bedridden, for folks that are aged, and these kinds of things that you learn right here also have applicability there.
Our next question is from an amazing all-girls school in Atlanta, Georgia.
Hello to the crew of the ISS from the Coretta Scott King Young Women's Leadership Academy in Atlanta, Georgia. Captain, what recent NASA researches or inventions might help with Earth's depletion of natural resources?
Okay, these are great questions, and that's a particularly good one, and it's very timely in this day and age. Some of the research we're doing, including in some of the research in the racks that are off to the left side of your field of view right now, actually answer some questions about fundamental processes in combustion. When we're here in low Earth orbit, orbiting in the space station, we can essentially isolate the gravitational effects that influence or produce convection that cloud a lot of the science of combustion research on planet Earth. And we can do it on fairly large scale here. We can suspend droplets of fuel completely independent of the gravitational effects, independent of any structure around them, and very precisely study how the combustion process unfolds. And it's helping us, on the one hand, design better fuel systems, better fire suppressant systems for spacecraft, but it's also helping us to understand at a very fundamental level how to make the combustion process cleaner, so that we can produce, we can essentially combust fuels on planet Earth and do so without polluting the environment, and perhaps do so more efficiently than we could otherwise do. Another thing we're doing up here, which I think also would help a lot with usage of Earth's resources, is the closed cycle, the closed loop life support experiments that I alluded to in the first question. And essentially what we're trying to do is remove the dependency on resupplies to bring vehicles like the space shuttle, for example, to bring us water, for example. If we can reclaim as much of the water that we exhale as water vapor, the water that we through normal processes, through urination, get rid of, instead of throwing that away, if we can reclaim it and process it just like you would in a very, very capable sewage processing system on planet Earth, if we can do that on a smaller scale here in space, then we can greatly increase our ability to use water more effectively on planet Earth, and also to leave low Earth orbit. So for every pound of stuff that's on space station right now, it takes about 20 to 25 pounds of high explosive in the form of rocket propellant to get it up to low Earth orbit. And so it's very, very expensive. To get me here, it took an awful lot of fuel. To get the water that we, in past years, have brought aboard to drink and to, through electrolysis, break down into oxygen for us to breathe, to bring that through space shuttles or other kind of cargo vehicles is a very expensive proposition. In fact, it would be a game changer. It would be a showstopper if we were going to leave low Earth orbit and go to Mars. You could not do it that way. So if we can figure out a way to very, very carefully process the waste products here on board space station, and we're pretty successful at doing that right now, and recycle that, then it has applicability on planet Earth as well. It's very, very difficult to do desalinization, for example, and to take water that's undrinkable and make it drinkable. And this technology we have here right now is being used in a lot of third world countries and disaster zones on small scales to basically provide a very good, very effective reverse osmosis means to purify water.
Our next question is from the Maritime Academy of Science and Technology in beautiful Virginia Key, just off downtown Miami, Florida.
Hello from Mass Academy in Miami. Captain, is there research on the ISS today that you can see having a lasting impact on the way we do things, like the way Steve Jobs changed our lives with the Macintosh or the iPhone?
Great question. Those kinds of things that radically change the way we live, often are unpredictable. And the work that we're doing on space station right now hasn't generated that level of a change. But it's the kind of thing where as you're doing various research and investigations, it's the kind of things, the aha moments, the wow, that's kind of funny, I didn't expect that, those kinds of results, and they're very, very difficult to predict. So there's a lot of research going on right now, literally hundreds of experiments, and already hundreds have been done on space station. It's not just work done by the 6 crew members out on board space station. It is in fact done by thousands of people all around the world. And when we're sleeping, a lot of work is also being done. So that data is being collected, and we're all very hopeful that a lot of very important things will come out of it. But right now we're living on a frontier, and this is a difficult thing to do. It's difficult to keep humans alive here. It's difficult to keep equipment functioning here. So we're very happy to do all those things and also try to push the frontier a little bit in science research.
Back up north, our first question from an incredible local school, our STEM Magnet High School in New London, Connecticut.
Hello, Captain. We are from the Science and Technology Magnet High School of Southeast Connecticut.
We read that a new spectrometer has been added to the space station. By using this machine to analyze cosmic rays, have you discovered anything new about antimatter in galaxies?
And this kind of goes back to that last question as well. Lots of data has been gathered. Millions of particles, galactic cosmic rays, and antimatter particles have been gathered by the alpha magnetic spectrometer. It's going to take a long time and a lot of processing of that data to be able to figure out the kinds of questions, the big questions that machine is designed to answer. Specifically, when we look at space, most of what we see is actually a small fraction. All the things that glow, stars and things like that, or things that shine with reflected light, all of those are very, very small subsection of the matter of our universe. So dark matter is roughly 2/3 to 3/4 of what we would consider as fundamental matter, simple, made of baryons, made of the kinds of things that we're made of. So a lot of it just doesn't shine. It doesn't shine at all. We don't know why. The AMS will help us answer that. But beyond that, there's still another vast majority of the constituents of the universe that we would call dark energy, and we don't even know the nature of that. So it's an important experiment, but it's going to take an awful lot of time.
And on to the second question from Baltimore.
Captain, do you think there could be Earth-like life on one of the planets orbiting a star that's visible in the sky?
There's a lot of great experiments going out right now by other vehicles. Kepler, for example, is one of them, and a lot of research being done by observatories on the ground, run by people all around the world. And I think when you just look at the numbers, to me, it's highly likely that there's going to be many Earth-like planets orbiting stars that are very similar to our sun, and many of those planets will be in what we would call the habitable zone. There are hundreds of millions of stars in the Milky Way galaxy and hundreds of millions of galaxies in the universe, the known universe. So I think it's highly likely that there will be, but it's going to take a long time to find them, I think.
Continuing south, we have question number 2 from Atlanta.
Sir, a really practical question. How do astronauts do laundry on the ISS?
I think I missed the question. If you could repeat that, please.
Sir, a really practical question. How do astronauts do laundry on the ISS?
Okay, how do we do laundry on the ISS? In a word, we don't. Right now, we don't. And that's something that there's being some work done already on the ground to work towards that goal, but it's a really difficult thing to do. Taking a shower up here is not a practical thing to do as well. So we clean ourselves essentially by taking a sponge bath, if you will. And that works, and it even works for 6 months. You'd be surprised. But the clothing, we essentially have new clothing, and we pack it efficiently, or the people on the ground to pack it efficiently and send it to us, but we don't change clothes quite as often as you do on the ground, and we don't have a practical means to clean it. And it's probably not an effective use of our time, I think, right now.
Dan, I pictured your clothes hanging on the treadmill. On to question 2 from Miami.
Captain, is the ISS involved in the aeronomy of ice in the mesosphere research? And do you think this research will help us control climate change?
Yeah, the AIM mission is designed to investigate what we call noctilucent clouds or night shining clouds, also called polar mesospheric clouds. And I don't think that anybody at this point fully understands the mechanism and how these work. From space station, we can see them, we image them, we send those images to the ground, and that contributes to projects like AIM. But we don't specifically have any direct tasking to do that. Polar mesospheric clouds are a relatively new phenomenon. At least they're more frequent now than they had been in years past. And whether that's tied to global climate change is really, I think, unclear at this point. It's very interesting. They're very beautiful to see, and we take a lot of imagery of them and we send it to the ground.
And we're back to Connecticut for question number 2 from New London.
Hey, Captain, I'm CJ Parker, and this is Kyrie Kadir, and our question is...
Sir, has there been any experiments on the ISS involving non-human animals, and what might future experiments be like?
There has, and I don't know a lot about the details of them. We've had spiders up here, and we've studied how the effects of weightlessness influence their construction of spider webs, for example. I imagine there are some plans down the road to. Right now, on board Space Station, we don't have any. There are not any specific plans towards that. Depending on your definition of animals, we do, to a degree, and have done a lot of studies of microbial life, for example. For some reason, and it's not entirely clear, a lot of microbes become more virulent and more hazardous to humans in a weightless environment. And it may have to do with the radiation of space. It may have to do with weightlessness. I'm not sure that we know entirely. But for example, salmonella, there were studies done on salmonella up here, and the fact that salmonella would change in the space environment, and you could compare that, the salmonella from space to salmonella on the ground, allowed researchers on the ground to identify the gene that was different, the controlling gene effect, that effectively, resulted in that change, and that's helping to allow teams on the ground to design drugs to specifically target and combat salmonella poisoning, for example. It looks very promising that the same thing could be done for staph infections or methicillin-resistant staph, and it's MRSA sometimes called. So we're doing studies on that level as well. And interestingly, at the same time that some bacteria and microbes become more virulent, the human body immune system actually gets suppressed to a certain degree. So ours is not as effective up here. Thankfully, we've all been pretty healthy, and it hasn't been an issue, but it's an interesting effect.
And we're back to Baltimore.
Captain Burbank, what is a typical day like on the ISS?
I think the typical day on ISS is atypical. There's really no such thing as a typical day, and that's actually one of the beauties of it. It's a delightful place to work. Every day is different. Every day is spectacular in its own right. Every day you have the opportunity to go to the window and look at this unbelievable planet from the vantage point of 240 miles above. We get to do everything from spacewalks to robotics operations to science experiments to just living and being in space, and it is one of the neatest parts, but every day is different. The opportunity to talk to great kids with phenomenal questions like you've got, for example, is a real treat that we occasionally are fortunate enough to have.
Well, no time for trips to Taco Bell. And we're on to Atlanta.
Hello, sir. My name is Brianna Gresham.
Jasmine Rogers.
Ashley Smiley. Sir, in 108 years, we've gone from the Wright brothers' first flight to the ISS. How long will it take to develop an aircraft that can travel at or near the speed of light?
That's a good question. Some bicycle makers a little over 100 years ago made an airplane when most folks on planet Earth didn't think that was ever possible. I think a lot of folks on planet Earth, including some very educated ones, think that creating a spaceship that'll go to the speed of light is impossible. So it's kind of hard to say at this stage to predict in the future. I would say this, though, that the physics that made airplane travel possible was relatively well known, or at least it was the kinds of effects. We could see how birds fly, for example, long before 1904. It is another leap, many orders of magnitude more difficult to contemplate going to the speed of light. It's going to require an entirely different set of physics, or entirely fundamentally different understanding of physics for us to get to that point. I think it's a long ways out.
Well, unfortunately, we're short of time. There's a whole long list of questions. Captain Burbank, all the students who've asked questions, who are listening, who are waiting to ask questions, thank you all for this great event. Dan and the crew have an incredible journey, and we look forward to your return home on the 16th of March. This is United States Coast Guard Academy turning it back over to you.
Okay, and thanks again very much. And I apologize for the folks that we weren't able to ask their questions today. These are great questions, tough questions. You had me sweating, so I was probably a little more long-winded than I needed to be. But I would just encourage you to continue to pursue these kinds of interests. This is the engine of our future. It is the ideas and the energy and the mental power that you have and you're already displaying. So I think we've got a wonderfully bright future, and we have a bright future like that because of kids like you. So keep up the great work, And down the road, if you'd like, we'd sure love to have you join us in the space program.
And station, this is Houston ACR. That concludes the event. Thank you.
Thank you, United States Coast Guard Academy. Station, we are now resuming operational audio communications.